What is up? I just switched to StreamYard, so still trying to figure out how this works. I have no idea if there's music coming through or not. Whatever. All right, so we are now on part 3 of the Learn Python on AWS. So far, we've been able to cover quite a bit, including variables, data types, Python packages, functions, arguments and parameters, inputs, loops. So yeah, we've learned a lot so far. Up next is if statements. So add in, we're going to add a little bit of logic to what we've already learned. I'm going to go ahead and share my screen now. Hopefully this works. It's a little different. I'm going to remove the background though. I think that looks a little bit better, hopefully. So let's see here. I got this sweet production thing going on now. So yeah, like I said, we're going to go through if statements. See that down there? I'm gonna go ahead and hide that now. So, okay, so back to it. If statements add decision making logic to your code. The if statement is used to match a defined condition to a true or false Boolean outcome. So with an if statement, we can start to introduce different paths through our code and provide different outcomes depending on our inputs. So in this chapter, we'll look at how to define if, elif, and else statements in our code. So I'm going to add a new notes section here. At today, if statements. I think that looks pretty good. Like, hopefully I don't have to zoom in. I don't think I have the ability to zoom in on StreamYard, but still learning. All right. All right, so the if-else statement. We'll add some conditional tests using the if statement. For example, imagine if you want to perform some input validation to make sure that the parameters provided are valid values that Amazon Translate will accept. Sometimes we want to check if two values are equal. We cannot use the equal sign as that is reserved for declaring a variable. To check if two values are equivalent, you need to assign the equal sign. So actually, well, we already know that that the equal sign is for variables, but I think that's something worth noting, that the equal sign is to make sure that two values are equivalent. So where two values are equal, this will return a true and where they're not equal, it will return a false. So we can combine this with an if statement. You can test this using the following code in your IPython environment. Just gonna copy and paste. So I'm not trying to type it all out. So then the equals sign is to see if they're equal to each other, right? Which we get a false returned. Right, yeah, so if we change, I wonder if we could just change this to French. And then if we try to compare it again, now we get true, because we were able to change the variable value from English to French. Now both source language and target language are equivalent in their values, so we get true. Okay, so looks like we're going to create a new file here, save it and say if statement .py. Well, I'm just going to copy this in. Okay, and then it looks like we use JSON loads, which we learned about the other day. Let's see. JSON loads used to input and outputting JSON from strings into strings. Okay. So we're defining two variables to store the language code from the input. Okay. All right, so now we have this if statement that checks to see if the language code is the same as the source code, which obviously we don't want. So if source language code equals to target language code, print the source language code should not be the same as target language code. Okay. And then we say, so if those do equal each other, it will print that. Otherwise, or else, we want to print The source. Okay, so we're just gonna just make sure that they're not the same. To source and target are different. So basically the same thing. Okay, and so if we run this, we should see that they are different because it's up here in our JSON string. So Python if statement. Did I do something wrong? I don't think it's got to be a typo somewhere, but I copied and pasted the. So we import JSON, we define the JSON string, we load it into this variable, we get the value of each of these and assign it to this variable. And then we say if source language code equals target language code, print this, or else print this. So why didn't it print the else, from the else section here of the if statement? I am not sure. Let's try and run it again, I guess. Let me try to say print test. Oh, weird. So now it printed right here, and then but it also printed. Maybe I just didn't save the file or something. Oh, now it works. Yeah, I must not have saved it. So that was weird. Yeah, so if we change this to French, though, save that, and then run it again, we should get a different print statement that says these should not be the same. When using if statements, you will often be using different operators to determine equivalence. Here are some of the operators that Python supports. I think this is probably a pretty useful little table here. See if I can copy that into our notes. I doubt it, but worth a try. Oh, wow, that's nice. These are operators. Notion coming in with a nice little table here. All right, so step 2, checking values in a list. Amazon Translate will only support a defined list of languages. The list of language codes that Translate will accept are provided in the developer guide. So if we look there, we can use an if statement to perform some input validation to check that the language code is in the list. If a wrong value is provided, Translate will raise an error. We will deal with handling errors in a later chapter. So let's create a new file. I'm going to say, I'm going to call this like validation.py, something like that. And I'm also not going to type all of those either. So there's our list of languages that are from the docs here, looks like. Wow, there's a lot. How many, I wonder how many languages there are total. It's really cool. Anyways, squirrel. Okay, so then, again, here we add our JSON string. We load that JSON string. And again, we sort of like parsing that JSON to get the values of what we need. And then again, we run this. Okay, so I think this is kind of interesting. So if source language in languages, which is our list, and print source language is valid, else print the source language is not valid. Save that, and then clear the screen here. And then if I run Python validation, we get that the response is valid, right? Because both English and French are in the list of approved or valid languages. But obviously, like if we change this to like, I think last time I tried to guess a country code, I thought Germany was GE, which is so wrong. Or sorry, German. Germany is not a language; it's a country. But German, and then if I run this again, it is not that source code. That language code is not valid. So it's good to have that, input validation, that logic to make sure that the code works properly. So, all right, step 3 is elif. So in the previous example, we checked the source language code and not the target language code. In this step, we'll introduce an and statement and also the elif statement. The and statement is a logical operator that combines the check for both source language and target language. The elif statement allows us to introduce multiple different logical checks. Okay, so that all looks the same. Okay, so uses an if elif else statement to check that the source language code is in the list of languages. Okay, so yeah, this is where our logic gets a little more complicated, but also kind of saves us from ourselves in a way. So if source language code equals target print so here's where we use the elif, and it's interesting because you can see like the if doesn't have like a colon, but the else does, right? So like I wonder why, like, you know, the if elif doesn't have it, but the else does. Not sure exactly why. So elif source code language not in languages and target language code not in. So if both are not in the list of languages, print, oops, did I? Oh, yeah, sorry, elif. Neither of the codes are valid. Let's just keep it simple here. And then another elif that says, okay, so we're checking to see if source code is not in. So neither, or we're checking to see if neither are in there, if only the source code is in there, or if the target code is in there in the list of languages. Covering all of our bases here, right? The source code language is not valid. If target group not in languages, print target code language is not valid. One more, I think, right? So elif. Oh, so now we're checking to see if both are valid. So if source language code in languages and target code in languages. Print the source and target are valid. And then finally, we just need our else statement that says, that's just, I guess the else here is just sort of a catch-all. Like if the logic doesn't meet or doesn't match any of our, statement or if or elif statements, then, and it gets sort of like all the way down to the end of this, if else statement, then you're just sort of printing that there's an issue. So save that. And then if we run it, let's say, yeah, okay, because we still left it as GE. So if it caught it here, because the source code language is not in the list of languages, right? But if we change this back to English, should say both are valid. Yep. Let's try one other one. Like, let's say like both of them are not valid. So GE, I don't know, like LM. I don't even know what language that would be, but yeah, so neither of the codes are valid. That's where we get the, if both are not in the list of languages. Cool. Okay, so yeah, it gives us some test scenarios, which we kind of just covered. Cool. Yeah, I mean, pretty straightforward. Not really like groundbreaking stuff here, but this is the last one for the if statement. So add input validation. In this step, we're going to add our input validation to our main Python file, breaking the problem down into smaller parts called decomposition. By tackling each element separately makes it easier to solve big problems. So in the code below, we've added our input validation as a function. Each if, elif, else statement will return true or false Boolean values. We've added a call to the input validation function, to the for loop in the translate loop function. Okay. So let's go ahead and add a new file, and we'll call it input validation. All right, so again, we need our imports. Just copy those. And here we just adding our args parse, right? And adding an argument to include a file. We've seen that before. So I'm just gonna paste that in. All right, so now, again, we'll have like a JSON file, and then this function will open that file up to get the contents of that file. Nothing really new yet, right? This has all been covered in previous sections, so I'm not really too worried about making sure I type it out and write through it. So here, again, very similar to before, just have that translate function, which has these parameters that are passed in that I'm sure we will define. Okay, so here, we have added a, did we add this in the loop section? I can't remember, but basically in this translate loop function, we're passing in the contents of the JSON file and for item in, that this input text, if input validation equals true, translate the text, else raise a system error. So this is kind of new, I believe, but for sake of time and effort, we'll paste it in. And we can play around with that later. But okay, so then we have another function here to add our input validation. So similar to like the previous couple of steps within this lab is that, we have this list of languages, and then we output that to a variable here that passes in the that data, and then we have our if statement to add the logic to sort of create that validation. So interesting, we have these return values. And that makes sense, right? Like, so you kind of look at this, because each of these, these if statements, except for this one, which basically checks that both the source language code and target language code are within the list of languages. This returns true because, that's sort of like, that's obviously what we're looking for. But the other ones are basically, we don't want to return a true value because these would indicate that there's like an invalid input. So makes sense, but let's keep going. Okay, so then we just have our main function here that calls the translate loop function, which is here. And this kind of kicks it all off, right? Yeah. So cool. Oh, did we oops. Went too far. I think we still have this translate input JSON file in here. So So just say, Python input dash 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 file translate input. Yeah, okay, we still have it. All right, so what did we get back here? Nice. So it was able to check that both the source code and the target language code exists in the language list, and returned that they are both valid, and proceeded to perform the translation for the data within that JSON file. So let's see if we can, again, like, where's our, oops, what was it called? Translate input. So what happens if we, again, if we change this to GE, and then if we run it again? So yeah, so we got the system error, which is from, from this. So once it said look through the input validation function and received a false, it doesn't call the translate text, right? It comes down here to raise that system error. Right here, yeah. Or here, yeah. Cool. I think we sort of talked through that enough to break it down. All right. So now we're going into logging. Looks like there's 3 steps in here. All right, so in the previous section, we used some if else statements to add some input validation to our code. This checked that the source language code and the target language code value were valid and printed a message. Adding messages to our code that provide metadata information about the code is executing. How the code is executing is known as logging. Logs are useful in many ways. They can help pinpoint the flow of information in our code, as well as where errors are being generated. Normally, we do not want to display our log messages. We want to see the output of the program and only refer to the log messages if we need them. So how to add logging to our code to separate out the information we want to return to the user and the log information we want saved into a log file. Logs for code running in AWS, for example, and Lambda function are sent to a service called CloudWatch. CloudWatch logs can be accessed via CloudWatch logs, log groups. You can read more about CloudWatch in the documentation. All right, so in this section, we're going to use a function in Python for logging. This is included in the core packages of Python, so we don't have to add it using pip, but we can import it straight into our code. The documentation for logging provides prescriptive, I'm going to click on this, prescriptive guidance on how to use the logging package. Logging allows us to, oh darn, I forgot to use my cool banner, right? We are now learning logging, Python logging, I should say. But so this is the logging section. Nice. Yeah, okay. Anyways, let's see what the docs look like, right? So logging, this module defines functions and classes which implement a flexible event logging system for applications and libraries. Sorry, just playing around with StreamYard here. So, okay, so back to the lab here. Let's continue going through this here. Some good stuff from the documentation, looks like. All right, let's move on. Hopefully there's some code that we can write. Okay, so simple logging. Let's see how simple it actually is. So in this lab, you will replace the print statements, which like print is how I debug things. I like you saw in the one of the previous examples, like sometimes I'll just add print statements within like a Python script just to see like how far down the script it will get. So, but you know, let's see. Apparently, logging is simple, so it'll be kind of nice to see if there's a better way of doing it instead of print statements all throughout my my code. So using logging allows us to return information about how the program is functioning. Using methods like print allows us to return information to the user. Let's see, so we can create a new file. Let's go ahead and do that. Logging.py. looks like we are, from previous examples using the same, loading in some JSON. Pretty standard at this point. So we can perform some logging functions, right? Yeah, again, already went through this. Oh, okay. This looks like it's from a previous example, but maybe we'll make it better because this looks very familiar. We've used print to output messages to the console. This is where we need to make changes to the code and add them to logs rather than output to the console. First, we need to import logging and then amend the print statements with relevant level for the relevant level for the message. Okay. So come up here, just import logging, which I didn't know was part of the standard library, but learn that now. Okay, that all looks the same. Okay. So basically, we get rid of our print statement. Oops. And we say logging dot warning. You know what? I guess I could have just changed it to print statement instead of rewriting all the. So we're literally just replacing the print statement or the print function. Info. Oops, spelled warning wrong. All right, let's run that. This should return nothing to the console. This is because by default, logging level is set to logging.warning. Because the code is correct, it does not generate a warning. It says that it doesn't have an attribute for info, though. Curious if good old Google. Let's see. That's not the. wonder if I can search through the docs for I'm not sure. I'm not sure why we got that message back. Oops. Anyways. Okay, so yeah, if we change this to the same, maybe we'll get an actual like logging message. Something's wrong. So if source code, we just imported logging and then changed print to logging dot warning. I don't really get why. Anyways, hopefully that doesn't screw up anything in the future. Okay, so what did Python do? When Python checked the if statement, it only printed a message to the console when the if statement returned false. This is because logging.warning will print to the console, otherwise logging.info level will not return anything to the console. I guess that's pretty useful to make note of, right? Like knowing that warning will actually print to the console, but info will not, even though for whatever reason we're not getting. Well, I guess it's weird. I guess like it's still working because we're getting this, you know, when the language codes were correct, we got this message, but when it wasn't, I wish they kind of gave us like what we should expect out of this, but anyways. Log level and log file. The default logging level is set at warning. This can be changed so that we can capture more or less information in the log files. In the last example, only the warning returned a result to the console, meaning we didn't see any other log data. In this step, we're going to change the default log level and save our output into a local log file on the Cloud9 instance. This is done by adding the following line to configure the logging level. Okay. So it says set the log level in the basic configuration. This means we will capture all of our log entries and not just those at warning or above. Okay. I'm just going to modify our existing file here. Let's add that line. Oops. Okay, and so everything else looks the same. All right, guess we just add that line to it. And then we run it again. Changes back to English. But I think I'm failing at this logging section pretty hard because I don't think this is. Yeah, it doesn't like these. Hmm. It doesn't even see that. So let me try to see if basic config. Logging dot basic config. I mean, there it is. Interesting. I am not sure why we're. Said it was like logging was part of the standard library, right? So it's not like we have to like pip install logging. Right? Thought logging was supposed to be simple. Not today. Hmm. Well, Logging might not be, I'm not sure why this is not working. Let's try this. No one has an answer for that one? Oh, wow. It's because I called it logging.py. Oh my gosh, because I'm importing. Oh man. Facepalm. Oh boy. Oh man. How do I rename this? Logging section. All right. So now I bet if we run Python logging section, well, we didn't get a response. So let's see where we're at in this mess. Okay, so I ran it, run it with source language code set to English to French, and then check that the example.log. So I guess it generates a log file now, right? Example.logs. Yeah, here it is. Oh, nice. Okay. So it gives us this cool, let's see if I can wrap the text here. There it goes. Okay. So we got info, the source and code languages, or source and target language codes are different. So if we go back into here and say FR, which is the same, and then we run it again, should get another output. Okay, so we get the warning. I like this. Okay, so it outputs like our sort of our input validation to a log file. Not too shabby. Instead of trying to debug within the terminal here, right? It's kind of nice to be able to go to just a log file and sort of look through that to see what's going on. Okay. Now that we got that, naming the file. Oh man, I gotta let myself down for that one. Okay, so add logging to our code. This step, add logging to our main code building on the previous step and labs. This will set the default value to warning and output the logs to a file. Okay. Okay, yeah, so similar to previous sections. But I'm going to do the same thing where it's just copy and paste a lot of this, since it's a lot of boilerplate from previous sections. I'm actually just going to get rid of all that. Okay. So that opens up our, what was it, JSON, which I also need to update too. So where is that JSON file? Right here. Change this back to English. Okay. So we pass in that file, the file name of that translate input.json, go through and parse the args, and then open that file. Then we have, again, our translate text function. Okay. And then we have our translate loop. Looks all pretty normal. We have our input validation function. But look, it's using the print statements again. So I wonder if I'll just copy this whole thing, actually. I'm assuming further down here is going to make us replace these print statements with some sort of like logging. Oh, okay. So it's kind of testing us here. So it's cool. So import logging. Set the default log level to debug and log file to translate translate.log. So I'm going to need to refer back to this section here to get this line, right? And this goes right here. Okay, so this song is really annoying. Let me change that. All right. So we need to call this translate.log. That. Log level to debug. That looks right. Amend the if, elif, else statements to use logging with warning, debug, and info levels. Right. So this would be just logging dot warning, I'm guessing. Something like that. Because we don't want any of these to. But this one we do, we just want to write info, I believe. And then something like that, maybe. I'm not sure. All right, let's run it. See what happens. Oh, we need to pass it a file name. Translate. Input. So if we look in translate log, oh boy. Interesting. So we did the import. Let's go back over to our code here. So looks like we got the name right. I think if you scroll over, yeah. Oops. Looks like we got that part right. Yeah, okay. So oh, interesting. Okay, so they're adding a bit more information here to the logging. But for the most part, I think, yeah, like for our true statement here, for the most part, I think it's right. So cool. What did you do? Good question. So we imported logging into our code, set the default level to debug, sent the output to a local file called translate.log. Python has logged every event, including Botocore events, when using the Amazon Translate service, which we see in here. Ooh, looking for credentials. Hopefully they're not in there. Verbose logging using debug is good when you're in non-production environments, but you would want to set the level default, the default level to warning in production to only capture important events. Seems like a good little note to capture. Cool. All right. So now we are at errors and exceptions. Hold, wait for it. Wait for it. Look at that. I remembered this time to add the banner. Nice. That is some serious production there. I'm very proud of it. All right. So probably going to get through these through errors and exceptions and then call it. It looks like part 4 will include persisting data and building in AWS. Probably do that tomorrow. So, all right. So errors and exceptions. Let's add a new section here. Error. Oops. That is not the date. Errors and exceptions. All right. So errors are inevitable. Are an inevitable part of programming, as Amazon CTO Werner Vogels says. Everything fails all the time. I think I was at the reInvent that he said that, but I've definitely seen this quote from him before, and it's true. We need a way to manage errors using exceptions to help us identify and fix errors, as well as to make our code more stable and resilient. All right, so try except. In this lab, we're going to look at using try except blocks to manage our exceptions. We will start with a simple example before adding our code for Amazon Translate. A simple example, heard that before. So in Python, we handle exceptions using a block called a try except, which wraps around our code. Python uses the try statement to attempt to run the code and use the except statement if the code returns some sort of error. The Python documentation, which is here, details how to implement this. As before, we will start with a simple example to illustrate how it works. In this example, we're going to generate a type error and handle it with a try except block. So create a new file and add the following code. Yeah, I remember this example. So basically, these are two different data types. So this is going to fail. So Python erroring. Yeah. The code returns a type error because you cannot add a string value to an integer without telling Python to convert the integer to a string. That was a while ago that we learned that. So with this example, we're going to add the try except block. Oh boy, here comes the logging import again. Good thing I didn't name the file logging. I'm not going to live that one down. That was All right, so let's see. So basically, gonna try to wrap this print statement around a try, and indent that, except. Oops. I'm not gonna type all that. It seems like a lot. So, all right. So let's clear that and then run it again. So we get the output of this guy here, the warning from logging.warning. I'm just gonna try to say like error adding string to an integer. Cool. I like that. What we did, we imported logging, we added the try except block. In the except, we have specified what action to take in the event of a type error. We provided a logging.warning statement. It not provided logging with, okay. Adding multiple except statements. The except statement above will only work for a type error because we've specified this in the except statement. There can be multiple except statements which provide details on what to do in the event of different types of errors. So in this example, okay, so you can have more than just so we can say except value error. Oh, it's using these brackets to. Oh, I'm an idiot. I was kind of wondering why. We want to be able to see exceptions generated by the AWS services. These are returned by Boto3 using Boto core. We need to add an import statement to our code, and we can use the try except statement. An example is shown below. I'm just going to copy and paste this. Oh, there's no. Add error handling to the code. In this step, we add error handling to the code base. On the example in the previous step, create a new file called lab. Okay. All right. So again, with our boilerplate code here, so again, we have the imports. We add our arguments with args parse. We open the translate input JSON file. Then we can create our translate text function, our translate loop function. Here's our input validation. There's got to be a way to programmatically fill in this list of valid languages, because it doesn't seem very efficient to have to fill in each or hard code each language code into a list. I feel like there's got to be a way to fill that in with a loop or something. Okay, so moving on, and we create the two. Kind of like this. All right, so I just wanted to make sure it still works with this, but I like how it kind of tests you a little bit. It's like, hey, give this a try or modify it, see if you can come up with the right modifications. Modified code to include a try except block follow around the following functions. So open input. So would it just be try, and then you move this, and then accept, right? I'm going to cheat a little bit. Getting tired. Okay, so sorry, I went too far. Wait, I don't need a colon there. So first part looks right. Just wrap this with open inside of the try part, but okay, so file not found. That's E. Warning. Yeah. So again, just have to indent it here and put a try. Except client error. Yeah, so I mean the generally just sort of indent all of these, right? With the try, like most of your logic goes inside of the try section here. Oh, I guess we cool. Let's mess it up real quick and see like GE or something like that. Cool. So we get like the logging output, right, telling us that that source language code is not valid. That's good. What happens if they're the same? Yep, they're the same. So seems to be working. What else? What else was one of the? Oh yeah, like if we didn't, maybe if I spelled translate wrong or something like that. Just curious to see. Oh, whoops. Let me change that back. Hmm. Interesting. All right. So what did we do? We've added try except statements to each of the functions in the code. We've added Botocore client error. Cool. I think that's it. Yep. So now we are on persisting data, well, which I don't have a banner for, but oh, hold on. Persisting data. This will be for next time anyways. So, yeah, that's what I'm talking about. Persisting data. Yeah. So next time, I'm sure. I think tomorrow I'll probably be jumping on again, trying to get more of like a consistent date, or more consistent date and times that I can jump on this and um, continue learning. It looks like we only have 2 more modules left, right? So for persisting data, looks like an awesome little lab with DynamoDB, and then building in AWS. Looks like you get to go through some cool stuff. So um, yeah, so we will catch that tomorrow, and thanks for watching.